Welcome to the session on VSAN or Virtual SAN. My name is Cormac Hogan. I work in the tech marketing team at VMware and I do a lot of storage related stuff. For the past year or so, I've been involved in the VSAN project. A little bit about VSAN. Do you know that we're running a beta on Virtual SAN? How many of you know we're running a beta? It's pretty good. Okay. Oh, awesome. We have some dimming. I would urge you all, if you have any interest, and you've come to the session, so you must have some interest in VSAN, I would urge you to sign up. It's very straightforward. It's just vsanbeta.com. And what it does is it gives you access to our beta community, and there you can get a whole bunch of documentation around VSAN or Virtual SAN. And if you are actually testing VSAN, how many of you are actually testing it and trying it out? Okay, a couple of you. We have R&D engineers also on the community, so if you have any type of deep dive questions, they're available to help you out. Okay, so let's move on to the presentation. I am going to just run through an overview of VSAN, give you a feel for what it is. Those of you who were in the keynote this morning would have heard Joe talking about it. He did say that Duncan Epping was going to do this presentation, but he's cried off, so I'm going to do it instead. Duncan is here with us, so he's also involved in VSAN, so we if there are questions, we can probably manage them between us. So what is a Virtual SAN? In a nutshell, what we're doing is we're taking your ESXi hosts, we're taking the local storage of your ESXi hosts, we are building a distributed data store that goes across all the hosts in that cluster. So we're taking a combination of SSD and your spinning disks, and we are building this distributed data store, not a volume, not a LUN, but a distributed data store type that goes across all of the hosts in that cluster, and all of the hosts in that cluster can use that distributed data store for the deploying of virtual machines. And it's fully integrated with all the core vSphere features that you would expect. There's HA, interop, DRS, vMotion, storage vMotion, and so on. What else about it? It is scale out. So we are starting with 3 nodes. We need you to have a minimum of 3 ESXi hosts in the cluster, but you can scale out to 8 in the beta, so you can actually have 8 hosts contributing storage, building this large distributed data store. The 8 limitation at the moment is a soft limit. We are hoping to go much higher. We may go to 16 by GA. We don't know yet. We'll still have to figure that one out. But the end goal is to be able to scale this thing out to follow along with our cluster size at the moment, which is 32 nodes. So that's what we want to get to. And maybe when we go to 64 nodes in a supporting the cluster, we want VSAN to follow along there as well. So it is converged. It's basically bringing your compute and storage together. It's also hybrid. I said we're using a combination of spinning disk and solid state drives. The SSDs, they behave as your I/O accelerator. So all of your virtual machine I/O goes first to the SSD, giving us that great performance that Joe mentioned in the keynote as well. And then we have these staging algorithms or elevator algorithms, which moves the data, the blocks of data, off of the SSD to your spinning disk. So I think that kind of covers, well, the one final point I guess we want to make is that it is radically simple to configure. Now I know we made the same claim around our vSphere storage appliance, the VSA. That wasn't quite so simple. This is, and I'll show you some demonstrations shortly, it is just the same as building a DRS or a HA cluster. So if you're familiar with doing that, setting up VSAN is exactly the same in just a few steps. So this is the radically simple part. First thing you'll notice, this is the Vsphere Web Client. All of our new features going forward are only going to be available in the Vsphere Web Client. So a lot of things we introduced in 5.5, like the very large VMDKs, the 62 terabyte VMDKs, the vSphere flash read cache, the VFRC mechanism, all of those features are only accessible and managed through the Vsphere Web Client. You can't manage those through the older thick C# client. So you need to be getting familiar with the web client going forward. Okay, so how do you set it up? As you can see, there's just a drop-down section here now for virtual SAN. In the general section here, you can see that there's a box that pops up and you turn on VSAN. At this point, you've put a number of hosts into a cluster. You have set up a VM kernel network called a virtual SAN traffic network on all the hosts in the cluster. Those are the only two things you need to do in advance. Once you have that cluster set up, go to this, select the cluster object, go to this general virtual SAN section and just enable VSAN. You have one question that you need to ask yourself, and that is whether I'm going to put this VSAN cluster into automatic mode or manual mode. What's the difference? The difference is how VSAN claims your local disk drives. So in manual mode, we're leaving the administrator decide which disks are going to be used for this distributed data store. In automatic mode, VSAN is going to go out, look at your local disks, find which ones are empty, and then build this distributed VSAN data store using those disks automatically. The other nice thing about the automatic mode is that as you scale out, you just drop a new node into the cluster. If you're in automatic mode, VSAN will look for the free disks on that node and scale out your data store automatically. If you're in manual mode, you just have to build a container object called a disk group to claim the disks. And there's an overview just here. I don't know if you can see it, but it tells you how many hosts are in the cluster, how many SSDs you're using, how many spinning disks or HDDs you're using, how much capacity is remaining, and is the networking okay? So in other words, are all the nodes in the cluster able to successfully communicate with one another over this virtual SAN traffic network? Okay. So feel free to ask questions at any point. Please do. So I did mention it's converged. It's bringing the storage and compute together. It is just with local storage that we're supporting right now. So no block storage, no volumes, that kind of thing. It is just going to consume local disk. And so basically, once again, just to recap, the SSD is your I/O acceleration device. It is not there for capacity. So that does not contribute towards any capacity in the vSAN data store. That SSD, which could be an SSD drive, but it could also be PCIe, will support that as well. That is simply there for I/O acceleration. The capacity or the amount of storage that you have, free space and so on, that comes from the spinning disks, the hard disk drives, the HDDs. Okay. So what about the scale out? Again, we're starting just with a 3-node cluster here. You can see it's consumed the disks and created this vSAN data store. If I had this cluster in automatic mode, all I have to do, add a new host to the cluster. When vSAN is already enabled, vSAN will go out, it will claim the disks again, it will grow the vSAN data store automatically, and then you just deploy your VMs. If you do it manually, we'll go through the building of the container shortly, but once again, you just claim the SSDs, claim the spinning disks, build that disk group container, and grow the vSAN data store. What is also very nice about vSAN, you can scale out on a compute-only perspective. So I could drop a stateless ESXi host into the cluster. It doesn't have any local storage. However, it can still continue to consume the vSAN data store. So as I said, it doesn't add any storage, so the vSAN data store remains the same size. However, the host that's in the cluster can access that vSAN data store and deploy virtual machines on it. Now, that is a nice feature. However, for the beta, and for those of you who are participating in the beta, you will notice we're recommending just for the beta to keep things as simple as possible. So in other words, use uniform hosts, similar disk configurations, get a nice evenly balanced cluster, just to make sure that everything is okay. We will put some guidelines around it at GA, what you can and can't do, but you can certainly do this But as I said, we just want to keep things as simple as possible. It is in beta. We just want to make sure that everything behaves correctly before we go to GA. So again, if you are participating in the beta, this is something you can certainly try out from a scale-out perspective, just putting compute-only nodes. But we are recommending that we keep kind of uniform configurations just for the beta. A question?
Yeah, I was just wondering, is there such a concept as a failure domain in the program?
So the way we explain it, I think everybody heard the question. The way we explain it is that the whole of the VSAN is almost like a hot spare. So essentially, if you have a component failure, depending on that failure, we will rebuild the objects that were on that component, whether it's a disk, whether it's SSD, whether it's a host. We will rebuild on the remaining capacity in the cluster. So essentially now, there isn't a way of divvying it up and just keeping, as you said, a protection domain or failure domain or whatever. Essentially, the whole of the cluster behaves as a hot spare. In the event of one component failing, we will rebuild whatever was on that component elsewhere in the cluster. Okay? So the other point I wanted to make as well, and this is something that seemed to have, I don't know, just basically when we did the initial announcement, with a lot of people comparing it to VSA or storage appliances. The main thing about VSAN is it's completely built into Vsphere 5.5. So all of the components you need for VSAN are in ESXi 5.5 and in vCenter 5.5, both the Windows version and the appliance version. So there's no pushing down of appliances, there's no installation of VIBs, there's no agents that need to go into virtual machines or anything like that. VSAN is baked into vSphere. So I just wanted to make that point. And so, I mean, that helps as well from a management perspective, because you're not managing appliances as well as your virtual machines. So the whole thing is baked in. And I think this is probably very key as well. We're now going away. Just out of curiosity, how many of you have a VASA provider? How many of you use this? Yeah, so some of you have VASA. So VASA is a storage awareness. It's basically a set of APIs that can surface up features of your storage array. And how many of you have used profile-driven storage in the past? So what we're doing now is we're bringing profile-driven storage and VASA, and we're bringing it to the next level. Now, VASA and profile-driven storage, that really, when it came together, it allowed you to choose certain data stores on which to deploy your VMs. So it kind of broke the data store list out for you, telling you some data stores had certain capabilities, other data stores had other capabilities. What we're doing now, and we continue to use VASA, but we now have what's known as, it is similar to policy-driven storage. It's still VM storage policies. But we're going away from the creation of LUNs, we're going away from the creation of volumes, and then placing virtual machines on those LUNs and volumes. What we're doing now with policy-driven storage is that you will define in a policy what the characteristics of the application running in the VM requires. What are the storage requirements for your applications? So you will build this policy, and we have things like a stripe width, a mirroring factor, flash reservation. We have kept it quite simple initially, but this is where we think, or where we feel things are going to go. So many of you may have heard of our VVols, or virtual volumes project. You can almost think of this as the very first iteration of virtual volumes, where VMDKs now become storage objects in their own right. So with vSAN, you will fill in this policy, select it when you deploy your virtual machine, and vSAN will then instantiate your VMDK object based on the contents of this policy. So is my virtual machine VMDK, my virtual machine disk, going to be striped across a number of disks? Is it going to be mirrored across hosts? Or am I going to do some cache reservation for this virtual machine? Do I want to make it thin or thick? So all of these things now go into policy. Select the policy at virtual machine deployment time, and your VMDK object gets instantiated based on the contents of this policy. So that's where we see things going. And when the virtual volumes product or feature comes out, and that is taking a little bit of time because we need all of our storage array partners to get involved with us on that. You will see VMDKs become objects instantiated on storage arrays as well. Not LUNs, not volumes, but VMDK objects. Okay, so that's, in a nutshell, basically an overview of VSAN. We can get into some of the further details now. Any questions before we move on? Yes, go ahead.
Some kind of leveling when you scale out, do the data get moved when you add another node?
So not in the beta product. So what will happen is that there are placement algorithms that VSAN uses, and it balances based on the nodes in the cluster. But if you add an additional node, it won't rebalance the data. It doesn't move data around because that is very costly. But future provisioning of virtual machines will actually prioritize placement on the host with the most amount of free space, which is the new one you added. Yes. There is also the concept of a maintenance mode. Sorry, I'll come back here. There's also the concept of a maintenance mode, and that will actually move data off of hosts as well and redistribute it around the cluster if you chose to do that. I'll get onto that in a moment as well. And yes, go ahead.
Well, if you have two data centers, will VSAN have knowledge about the placement of where the data get mirrored?
Yeah, so the question is about stretched VSAN, I guess, essentially. We don't have a stretched VSAN feature yet. It is something that is on our roadmap because every time we present on VSAN, we get the same question. Can we stretch it? Definitely, it's one of the priority things we want to do. In order to do that, you're quite right. When we have mirrored virtual machines, we need to be able to place one replica on one data center, another replica on another data center. That is the functionality we need to bring in to VSAN in order to do stretching. But we won't have that in the 1.0 release. Any other question? Yes, down the back.
The beta builds that VSAN that people can use now, is it representative of the performance envelope of the beta target? Not for normal IOs as well as rebuild, reapps, post-beta?
Yeah, Chad, yeah, it pretty much is. Now, having said that, we continue to tweak various things internally, not something that is customer facing, but we do continue to tweak things to get the best possible performance out of VSAN. But I would say that with the beta refresh that just took place last week, we're probably very close to what we'll have at GA.
I'm curious, are people really buying beta? If not, why not?
Yeah, there's a few people, a lot of people know about the beta. There's a few people who are trying it, or else people are very shy and not raising their hands, I'm not sure. But it's, yes, go ahead.
Oh, sorry. There's only 2 hosts in the cluster where the test plugin applicable.
Okay. Yeah. But so what I would say is that even if you join the beta, you do get access to the VMware hands-on labs. Now I know you can't really do performance testing there, but if you're interested in just trying out the workflows, trying out the policies, looking at the different layout of your virtual machines as you select different policy types, using the hands-on labs is a great way to just get some familiarity with it. So, okay, so what are the key components and considerations? Essentially, it's vSphere 5.5 is what you'll need. Now, this is just for the beta, so the components are there. If you join the beta, you get the license as well, which means that you can continue to play with vSAN. If you don't have that license, obviously it's going to expire. So it's baked into vCenter 5.5, it's baked into ESXi 5.5. You will need at least one SSD and at least one HDD on 3 hosts. So there's a minimum of 3 hosts. And the reason for that is that by default, when you deploy a virtual machine on vSAN, you're going to build a replica copy of the VMDKs. So you have a VMDK on host 1, replica copy on host 2, and then we have a quorum or witness disk that needs to go on host 3. And that's there for making decisions about when there's failures. You need to have a majority of votes left in the cluster. So here's the reason why you need a minimum of 3 hosts. Okay. Now, the SSDs, the spinning disks, there are a couple of limitations, or maximums, I should say, around that. This whole disk group concept, where we put SSD and spinning disks into a container, you can have a maximum of 5 disk groups. Each disk group will contain 1 SSD and up to 7 spinning disks. So if you work it out, you have 5 times 7 spinning disks as your capacity, alongside 5 SSDs. Scale that out to 8 hosts in the cluster, and then you have your maximums for your maximum size of a VSAN data store. I think you did some calculations. I think Duncan did some calculations, and we're up in the petabyte range. Yeah, so pretty big, pretty big. The networking is interesting. It will work quite happily on a 1 gig network, but you need to bear in mind that as you scale up, you're going to, or scale out, I should say, you're going to have a lot more traffic traveling on that network. So we are making a recommendation that you use 10 gig. Now, the nice thing with that 10 gig network is that we're allowing you to share it with other VM kernel port types, with other network traffic types. With VSAN, you will get a distributed switch. So that will be included in the VSAN feature. So you don't need Enterprise Plus. We will give you a distributed switch. With a distributed switch, you can use network I/O control, and so you can put a quality of service on your VSAN traffic if you so wish. So network I/O control does give you that. Yes?
Do you have a preference for jumbo frames?
Yes. So we haven't seen jumbo frames make any significant difference to fully loaded VSAN clusters. And due to the complexity of setting up jumbo frames and how you can very easily shoot yourself in the foot, I would say just stay away from them. Looks like you agree. Okay. So very good. I know we only have 45 minutes, and I do want to show you a demo as well. So what have we got here? Basically, network. Go with 10 gig if you can. We will support standalone switches, but if you go with the VDS, you get network I/O control, quality of service. Storage controllers, we continue to work with a lot of storage controller vendors. We're building a HCL or a VMware compatibility guide. And by GA, we should have a good list of all of the storage controllers that we support with VSAN and how well they perform. We're also grading solid-state drives. So we're going to class solid-state drives based on their performance and how well they work in VSAN as well. So all of that will be on the HCL, and then HDDs we don't really care too much about. So managing VSAN, what I did is I put together these 8 steps, and essentially above the line here you have the 4 steps where you're in your design phase. So you're thinking about what workloads are going to be running in my virtual machines, what are the applications, what are their storage requirements, and up here, after you've created VSAN, you will start creating your policies. So what kind of stripe width do I need, if any? How many failures to tolerate, which is basically the mirroring factor, and so on. The bottom of the line then is just the deployment mechanism. As you run through the deployment, what you're then doing is you're selecting a particular storage policy for your virtual machine. So you will then, and that's it. So you're not creating LUNs, you're not creating volumes, you're selecting the appropriate policy that you built previously for your virtual machines. Now, setting up VSAN is pretty straightforward, as we've seen it already. The only decision you have to make, manual or automatic. So do I want VSAN to claim my disks, or do I want to build my containers myself? And we already saw this as well. It's just really a matter of manual or automatic turning on VSAN. So what you end up with at the end of the day is this VSAN data store. So this is an aggregation of all of the local spinning disks that's on each of the ESXi hosts that's in your cluster. And this data store is accessible by each of the hosts in the cluster. It cannot be presented outside the cluster, by the way. So you can have other ESXi hosts leveraging this, mounting it, gaining access to it. The only ESXi hosts that can access this data store are ESXi hosts that are in the same cluster as that has VSAN turned on. Okay, so the capabilities, let's have a closer look at those. So there's 5 that we're putting in to the initial release. We do have lots of ideas about other things that we can put in here as well. If you guys have ideas as well, we'd be very happy to hear about what you would like to see in a policy. But the kind of things that we have in right now, and remember, we're keeping things as simple as possible initially, is number of failures to tolerate. So how many disk failures, host failures, network failures, and so on do I want my virtual machine to tolerate? In other words, to keep running, have a full complement of that virtual machine's data remain in the cluster after so many different failures. Now, it could be that it's a host failure, and the host that failed was also the host where the virtual machine was running. In that case, we have full interoperability with Vsphere HA. HA will query where there's another copy of the data available, and it will restart that virtual machine using an intact copy of the VM. So it's not fault tolerant. If the host fails, your virtual machines, some of your virtual machines will certainly go down as well. But because there's full interoperability with Vsphere HA, we can restart those virtual machines elsewhere in the cluster. Number of disk stripes. So that's basically a stripe width of your VMDK across multiple spinning disks. Object space reservation. By default, everything that we deploy on vSAN, all your virtual machines are thinly provisioned. What object space reservation gives you is a thickness. So if you really wanted to provision some space up front for your virtual machine, that's what that policy setting does. Flash read cache reservation. Our SSD does write caching and read caching. So it's split into, I think it's 70-30, 70% reads, 30% for writes. And that 70% of the SSD is shared by all of the virtual machines that are running on the host. They're shared equally. What you can do is you might decide, well, you know what, this virtual machine, very important to me. It would benefit from having its own cache. So what you can do is you can reserve some cache using this policy setting. And then the final one is the forced provisioning. So in other words, if I'm doing some kind of maintenance, or maybe I have some hosts that are out of the cluster for whatever reason, or perhaps, you know what, in a couple of days, I'm going to be adding some new hosts to the cluster, so it's going to scale out even more. What you can do is you can force provision virtual machines even though they can't meet the policy settings. So you can override. In other words, if you put together a policy and the resources are not in the cluster to meet the policy, the virtual machine won't roll out by default. But if you wanted to roll out because of whatever is going on in the cluster, and be aware this is something that you could shoot yourself in the foot with again, you can actually roll out that virtual machine even though it doesn't meet the policy setting. Okay, so these are really just the questions you ask yourself about the policy. What's the availability I want from my virtual machine? Do I want some additional performance? Do I want it to be thin provisioned or thickly provisioned? And do I want to deploy it even though vSAN can't meet those requirements? So those are just basically the 4 questions. As I said, we're keeping things as simple as possible for the beta and for the GA, but think of all the other storage features that you might add to a policy going forward. And this again is very similar to virtual volumes. These are the kind of questions that you'll have with virtual volumes, but certainly virtual volumes will have a whole bunch more policy settings based on the capabilities of your array. For instance, there might be deduplication or snapshotting, replication. All of those kind of things will be added to a policy as well. But for vSAN 1.0, we're keeping the policy as simple as possible. And so to set up the policy, this is just the landing page for your Vsphere Web Client. Go into your VM storage policies, and then you can create them to your heart's content and have lots and lots of different policies based on what your virtual machine requirements are. When you go to roll out your VM, you just select the appropriate policy. And those are the settings, you just set them like so. Okay. So what are the best practices? We actually are recommending you just go with a default initially, unless you have any pressing concern to do something different. The default policy when you roll out a virtual machine on a VSAN data store is just to have failures to tolerate set to 1. In other words, you get a mirror copy of your virtual machine. So even if you don't set up any policies and you roll out virtual machines onto that VSAN data store, your virtual machine is going to be made highly available anyway. So, yeah. And just to show you, as you go through the deployment of your virtual machine, you get to the section where you now select a storage policy. Select that storage policy. It drops all of your data stores into compliant or compatible and non-compatible. We use those terms interchangeably. But what this is telling you is that that policy setting, the VSAN data store understands that policy setting, but your NFS data stores or your iSCSI data stores or your fiber channel data stores, they do not understand it. So that's why it's breaking out into this compatible and non-compatible. And obviously you just choose the compatible one. Once your virtual machine is then deployed, if you go to the virtual machine summary page, you can actually see at a glance whether that virtual machine is compliant or not. So initially when you roll it out, it will be in a compliant state. However, what if there were failures in the cluster? What if I lost a host, or what if I lost disks or whatever, and there wasn't enough resources to rebuild? Then in that case, you'd get non-compliant. And actually it will stay in not compliant until the objects have been rebuilt, and so your policy setting is back to normal. For instance, if I've rolled out with a failures to tolerate set to 1, in other words, I must have a mirror copy, but I lost one host that contained a mirror copy, this will go into a not compliant state until that mirror copy has been rebuilt elsewhere in the cluster. Okay. One of the really nice things now is that you can actually visualize the layout of your virtual machine. So depending on whether you set a stripe width, a failures to tolerate setting, all of these things contribute towards a RAID 0 and a RAID 1 for your VMDK. And what you can do is you can go into each of your virtual machines, look under the storage policies section, I think it is, and what you see is a very nice layout of what your virtual machine looks like now. So you can see here I have a two-way stripe making up my the RAID 0s here. But then I also have a failures to tolerate set to 1, which means it's mirrored as well. And then we have these witness objects I mentioned to you. These are there for quorum, failures, deciding who's the owner of the object and so on. These all appear in the view for your virtual machine, which is quite nice. So you can actually visualize the layout of that VMDK. So a few more, just to mention, we did touch on this briefly, just the maintenance and monitoring. If you do have hosts where you need to do maintenance on, you can actually decide, just shut the host down, leave all the components on the disks on this host, because it's only going to be a very short maintenance window. I'm going to do something very quickly and bring the host back up and let everything resync. Or you could go another way, one of which is move all the components that are necessary off of this virtual machine. Let's rephrase that again. Move all of the components that are necessary to keep these virtual machines running off of this host, but don't move everything. Just move enough components so my VMs can continue to run. Or the final one is basically a full evacuation. Get all of the components off this virtual machine. Maybe you're decommissioning it completely or whatever. You can also do that. So we have various options available to you for maintenance mode on VSAN. Okay. Yes?
You put the virtual machine part of it into maintenance mode, or you have to put the whole host into maintenance mode?
So on VSAN, it would be the whole host that's going into maintenance mode. You can certainly migrate the VMs off. So you would do that with the host maintenance mode. That would evacuate the compute part of the virtual machines. But this is actually migrating the data that's on the local disks if necessary.
Okay.
Yep.
So if I just put the host into maintenance mode, that would be a no data migration state. And then if I then remove it.
So you mean here?
I put the host into maintenance mode, not through the VSAN, but just the host. migrated the machines away and then rebooted the server. Would that make it the same as the no data migration?
I think, yeah, I think that's...
Cormac, can you repeat the question?
Yeah, sure. So I think the question is about the maintenance mode that we have right now, where we can migrate the virtual machines off of the host versus what this migration mode is. So that migration mode is for the compute part. This is for the storage part. So there's two separate things that need to go on now. Actually, I think they work together now, Duncan, don't they? Are they integrated? So it would be the same workflow. It would move your compute off, and then you decide whether you want to move to storage as well.
Yeah.
Yeah. Okay. And just very finally, there's a number of different failures that can occur. These are getting bubbled up into the web client. You could have disk failures. So if you had a disk failure or an SSD failure, using SCSI sense codes, we can determine that this is actually a hard failure. So we'll rebuild the components immediately elsewhere in the cluster. So instantiate a new mirror or whatever the case may be. Host failures are a little bit different because it could be just a reboot. So the host could be gone down, but it could be coming back up again. So we have a tunable value of 60 minutes where we will wait for a host to recover. And if the host hasn't recovered within that 60-minute default timeout value, we will go off and rebuild anything that was on that host elsewhere in the cluster. If the host comes back after 62 minutes, what we do is we look at how far we have got with rebuilding the components versus what state the components are on the host, and we will decide what's going to be quicker. Is it quicker to forget about, just drop what we're doing on the rebuild and sync up to the host, or is it going to be better to just continue on with the rebuilding and we'll discard what was on the host? So we have that kind of intelligence built in as well. And just finally, from a performance perspective, so there is going to be interoperability with VCOps version 5.8, which I think will be out very soon. So with VCOps 5.8, you will be able to see a vSAN data store and look at all the features you're looking at with data stores right now. But we do want, well, one of the pieces of feedback we got when we initially started talking about this with customers is they didn't want this storage being a black box. Okay, they're fed up with storage being a black box. They want to see what's going on underneath the covers. So we have this observer tool to do exactly that. So using this observer tool, you can get right in there and you can look at the various performance on all of the disks in the individual disks, SSD, spinning disk, and so on. It'll pretty much give you any metric you really wanted to look at. So we do have that available as well. Yes, go ahead.
And you'll, of course, integrate that with the normal performance view.
So long-term goals, the question was, will we integrate this into the normal performance graphs and the Vsphere Web Client? Yes, that's the end goal, but that will take a lot longer to do. This is something that's, engineering we're using, and we thought, well, let's get it out there because everybody can use it. Okay, so let's have a look at the demo. Great. Okay, so what I'm going to do is just show you very quickly how to, yeah. So I'm just going to show you how to set it up, if it works. So we are into the Virtual SAN Manage section. And so what you can see in the cluster over here, you can see it, that there's a number of hosts in the cluster. There's 4 hosts already in the cluster. So I'm just going to turn it on. By default, it comes up in automatic mode. I'm just going to change that to manual. Okay, so you just need to go into disk management now. Now what I need to do is I need to build these disk group containers holding both my spinning disk and my SSDs. And you can see here I can just select all eligible disks. Now this is done in a nested environment. That's why all the disks are such a small size. But very quickly you can go and build up your vSAN cluster. So there we go. You can see the disk groups are now available in there. And they contain my SSD and my non-SSD disks. Let's see just a general overview. See there's 4 hosts in the cluster. There's 3 SSD used. There's 2 spinning disks on those hosts. But notice that there's also a host in this cluster that isn't contributing any storage, but it's still able to access the VSAN Datastore. Okay, and there's the VSAN Datastore. All right. So what I'll do now is I'll just go in and build some policies like we saw earlier. Very quick typing. And there's a bit of blurb about rule sets and so on. So my vendor, I only have one. It's VSAN or Virtual SAN. And there's my list of capabilities. So what I'm going to do is I'm just going to set my number of failures to tolerate to be 1. Just a little bit of blurb about what that does as well. VSAN Datastore understands that policy, so it's a matching Datastore, which is good. And just finish it off. And that's my policy built. I'm just going to create another one now. I should have picked shorter names, but anyway. Again, back in here, VSAN is my vendor. Now, at that point, think of when vVols becomes available. Here, you might be able to select your VSAN for one vendor, but you might also have our partners in there, or EMC, NetApp, HP, IBM, and so on. There's a whole list of partners who are involved with this program. When you select their particular vendor, then you'll get the list of their capabilities of what they can offer. So this time, number of failures to tolerate, I'll leave it at 1, but I'll also do some disk striping, and I'll set that to 2. Again, VSAN is happy with it, and just finish the creation. Okay. So there's my 2 policies created. Let me go and deploy a VM or a few VMs, and you'll get the idea. Put it on one of those hosts. And now when we get to the policy section, you can see here that I can select, you say the web development one. And then the Datastore is going to the compatible or non-compatible state or incompatible. So my VSAN Datastore understands the policy. NFS Datastore has no idea what I'm talking about. Okay, so let's leave that run away. Okay, so I'm rolling out a bunch of VMs at this point. So what I'm noticing then is that maybe my VSAN Datastore is starting to fill up. Maybe I should scale out some more. So let's just do that. And you can see I have a 5th host here, ESX05. So what I can do is I can move that host into the cluster. There you go. And that's done. So the thing is, because my cluster is in manual mode, I actually have to go in and manually claim these disks as well. So that brings me back to my disk management section in VSAN. So you can see there's no disk group associated with 5 yet. So what I can do is just create one and select the disks once again. And at that point, when that completes, go. Yeah, so now my VSAN Datastore has grown. So it was as simple as that. It's just a matter of pulling the host into the cluster. If my cluster was set up in automatic mode, I wouldn't have had to do anything extra. Because it was in manual mode, I just have to build that disk group. So we're okay for time, are we still? 1 minute. 1? Pretty close. So let's do one more thing. Let's have a look here at my policies. And one of the nice things is that, let's say you've rolled out your policies, but then your workload or your profile of your virtual machine has changed, and maybe you didn't size the policy correctly. What we can do is we can change the policy on the fly, which is a very nice feature. So here I have a policy. I'm going to add a new capability. Maybe I decided that I'm going to give some cache reservation. And this percentage value is based on a size of the VMDK. So it's 0.5% of whatever the VMDK is going to be allocated flash for this VM. And I can apply this on the fly. And what happens is that we leave the original configuration intact and we build a new replica or replicas based on the new policy setting. So we have the original policy setting still in place. The virtual machine continues to run. We're putting in place more replicas based on what changes we've just made. And you can do this on the fly with the virtual machine continuing to run. So if I just have a look here, we should be able to see. So you can see now that the virtual machine has gone non-compliant or not compliant because it doesn't match the policy setting. The policy setting is now taking place. It is reconfiguring. And when that completes, your virtual machine will go back into compliant state. And you can see the disk is non-compliant, and maybe down below the line here, you can see some components are in this reconfiguring state. But eventually, all being good, we just check the compliance there. Virtual machines that the policy on which I changed, they will come back into a compliant state once that reconfiguration is done. So I think we're out of time. Thanks very much for coming along. Please have a look at the VSAN beta, if only to get the documentation and have a read of it. vsanbeta.com is the sign up. Thanks very much.